Hey, I'm Steve Mignonti here in El Paso, Texas at MSD Performance. The new line of MSD DynaForce starters have plenty of torque to crank over any cubic inch displacement and virtually any compression ratio, but you gotta meet them halfway to get maximum performance. So what I'm talking about here is two critical measurements: gear mesh and depth of gear engagement. Every starter kit includes shims to fine-tune the installation as well as the proper bolts to do it right. Let's get started. The first step to all of this is disconnecting the negative battery cable. We don't want to do any impromptu welding down here. Once that's been done, we raise the starter into position and bolt it in without any shims. We want to get a baseline as to what kind of mesh we have. Sometimes you don't have to make corrections, sometimes you do, but you got to check every time. Another key thing is to use the bolts that are supplied in the kit. There's a knurled section here which will engage the block and ensure that the starter motor doesn't move and is properly aligned. Our first test is going to be checking pinion depth. Do that by using a screwdriver to pull the pinion out of the starter, and we can see that we have too much engagement. It goes almost to the edge of the flywheel. What we really want to see is 1/2 to 2/3 of the small gear engaging the ring gear of the flex plate. If we get a little too much, we will have to utilize the shim pack. Second test involves mesh. And what we want to see is between 20 and 30 thousandths engagement between the teeth on the ring gear and the pinion. A common household paperclip does a job great. We just slip this between the teeth, measure to see if it's tight, and we can see here that we are a little bit tight. Critical also to make sure that we take this measurement from a series of places, maybe 3 or 4 around the perimeter of the flex plate. That way we can rule out the possibility of a bent flex plate, which is a problem that we can't address here. Okay, our test installation shows we have to adjust both the gear mesh and the depth. We'll first address the depth. That's done by using these shim kits between the mounting block and the body of the starter. The ideal amount of engagement comes down to this. This is fully extended. You want to see this pinion gear go into the ring gear by about 1/2 to 2/3, no more. We've got a little too much engagement, almost the whole thing. Adding shims between the mounting block and the body of the starter will correct this. To reduce the amount of pinion gear engagement with the ring gear, we'll install the round inner shim ring and the outer shim as a team. They'll back it out about 60 thousandths and give us what we need. Okay, now we've corrected for the depth of engagement. That way this gear will disengage more quickly and get rid of that sound, that shrieking sound that you always hear when these things aren't set up right. Now we also know that we have a little too much engagement between the gears. We have to back it off a little bit, so we'll use these two shims to take care of that problem. Let's install the starter. Our mesh problem isn't that extreme, so we only need to use one of the two supplied shims. These go between the mounting block and the engine block and will move the starter gear away and restore proper clearance. The final step is torquing the fasteners to 32 foot-pounds. It took a little extra time, but it was well worth it. Now we know that our DynaForce starter will provide us with thousands of starts and many years of faithful service. Ah!